And we're going to start with measure of position. Now, as I said earlier, your stats project will be posted so you can get started on it. I haven't decided yet, but more than likely the final draft will be due close to the end of the semester. But I'll put a date before though, because I want you guys to submit it so I can give feedback and you can make corrections and then submit your final draft. Because I want you guys to do well on the project. All right, so we're going to start with what we call a percentile. So a percentile, or sometimes it's referred to as a percentile rank, indicates the percent of data values in the set below that particular value. All right, so let's do an example. So here is an example. The weights in pounds of 12 members of a college gymnastic team So the weight in pounds for 12 members of a college gymnastic team are below. And they want you to find the percentile rank of the team that weighs 97 pounds. So in other words, what they're asking you for is to find what percentage of the team's like the weight that's going to be less than 97 pounds. That's basically what they're asking you for. So the percentile rank will tell the percentage that is less than that particular value. All right. So these are the data values that they give us: 101, 120, 88, 72, 75, 80, 98, 91, 105, 97, 78, and 85. Now, it is important that you put these in order before you do your computation so you don't make any mistake. Now, let's order these. What would it be in order now? What do we have? 72. 72, 75, 78. Yes, 80, 85, 88. And then we have 91, 97. What else? 98, 101, 105, and 120. Are those all? count to make sure. I think so. I think we got them all. Have we? Yes. So basically, we want to find the percentile rank that 90 or 97 corresponds to. So this is 97 here. So what you're going to do is to find out how many data values are less than 97. How many of those are less than 97? Count them up. So count up all of these. 7. So find the percentage. It's going to be 7 divided by the total number of data values. How many data values we have in total? 12. And then times that by 100%. And tell me what you get there.
Can you say 100% gives me 100?
Yes, but we're gonna write the answer in terms of 100, in terms of a percent, so that's why, yes.
58.3.
So that's going to be 58. I'm going to use to the nearest percent, so approximately 58%. All right. So what this is telling us is that 97 pounds is the 58th percentile rank. Right. Meaning that 58% of the data values lie to the left of the 97 or less than the 97. All right, so that's what we mean by the percentile rank. Now, here's another example that we can be asked to find. Now, example 2, what if we're asked, look at this question here. The number of attendees at a particular staging of an event for the last 10 years are, so we have 485, we have 500, we have 506, 307, 250, 275, 865, 900, 450, and 670. And what they want you to find is, they want you to find the number of persons at a particular staging that corresponds to the 40th percentile. So remember that we need to order our data values first, right? So remember to order first. What would this be in order? 250. Then we have 275, 307, 450, 485, 500, 506, 670, 865, and 900. I think that's all of them, right?
Then
Yeah. So now you're going to ask yourself, how many data values do we have in total? We have 10 data values in total. And what percentile do you want to find?
40.
40, right? Do you know how you would find where that position is?
Counts from the board, not four from the beginning,
Right, because we know that. How do you know that you're counting for?
because.
40%? Right, so 40% of 10 is equal to 4. So it means that we want 4 data values to the left of that particular value. So this would be where the 40th percentile will be. Right, so 40% means 40 divided by 100. And if you times that by 10, that's how we get the 4. So we want 4 data values to the left of the particular value where the 40th percentile will be.
Yeah, 40,
Say that again.
yeah, 45. I'll say there's the fourth number.
No, this is it. Remember the definition of percentile? You want that percentage to be below
Oh, yeah.
that value,
Yeah.
right? So you want 4, which is the 40% of the 10 values, which is 4. So we want 4 data values to be below the 40th percentile. So this right here is where the 40th percentile will be. So not the 4th value, but you want 4 data values to be less than where the 40th percentile will be. Less than. All right, so that's how you would do it. Now, quickly, we're going to look at interpretation of quartiles. All right, so interpretation. Right? When you have quartiles, you can think of it as, let's say we have a box here, and we split it into 4 quarters. So this is what we will call Q1, the first quartile. This is Q2, and Q2 is the same thing as the median or the middle value. And this is Q3. And each of these would represent 25%. Do you agree? Right. All right. So when we talk about the first quartile, and this is what we call Q1, what we are saying is that 25% of data values are less than Q1. So that's like the 25th percentile. When I talk about the Q1, that's the 25th percentile. Now, Q2 is similar. So the second quartile we know that 50% would be less than Q2, because that's the median. 50% of data values are less than Q2. And this is also known as the median. It's the middle value. Your Q2 is the same thing as your median. And lastly, Q3, or the third quartile, we say that's, how much percent would this be now? 75% of data values are less than Q3. Now, there are some terms for us to define. We have what we call the interquartile range. And the interquartile range is simply Q3 minus Q1. That is your interquartile range. So far we have looked at different types of ranges. We looked at one, which was a central tendency. Which one was that again? The mid-range. Remember the mid-range? And then we also looked at the range itself on the measures of dispersion. And now we're looking at the interquartile range. So don't mix them up. There are three different things. All right. And we also have what we call the semi-interquartile range. What does semi mean? Half. So you're just going to take Q3 minus Q1, and then you're going to half that by dividing by 2. And that is your semi-interquartile range. Let's look at a few examples. So the data below shows the number of cattle on farms in the US. Number of cattle on farms in the US in millions for each year from 1910 to 2010. And then it is asking you to find Q1, Q2, and Q3 and represent the data on a box and whisker plot. All right. So these are the data values, and it's in millions. So this 59 means 59 million. 70.4 would mean 7.4 million. So it is still a discrete data. It's not a decimal saying we have 7.4 cows. All right. So this is in million, meaning 70,400,000. All right. And then we have 61. We have 68.3, 78, 96.2, 112.4, and then we have 111.2, 95.8, 98.2, and 93.9. Now, before you can find your quartiles, you need to first arrange the data, right, in ascending order. So first, we are going to order the data. What would it be now in order? So we have 59, what else? 61. 68.3. What else? 70.4. 78. Let me know if I'm missing any. Then 93.9. 95.8. Are we good so far? 96.2. 98.2. I think so far so good. And then we have 111.2 and 112.4. Yes, that's it. So first of all, let's go ahead and find our quartiles. So just go ahead and locate the middle first. And this is one way of doing it. This is the manual method where we don't have to use any formula, and I will accept it if you do it. But there are some times when you may want to use the formula, which I will still show you because it gives you it's more accurate. Sometimes it's the same as this manual method, especially when you have odd number of data values. But when you have like even number of data values, sometimes the manual method, like what we will do, and the actual formula method will give different results, slightly different, but it's okay. If you use technology based on the program that you use, you may also get different results because Microsoft spreadsheet may use a different calculation method from, say, another software, right? It won't be too far off, but you can get different results. Because you have different methods of calculating quartiles, and no one method is really better than the other. It really depends on what you're going for. It really depends, right? All have their advantages and disadvantages. Yeah, so just locate the middle, which is this the middle? All right, so you have equal number of data values on both sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, so this would be the middle. That's your Q2 or your median. And then now what you're going to do is look to your left now and find the middle of that.
60.
Yes, so this would be your Q1. And then do the same thing over here. Look to the left and find the middle of the right, and find the middle. 98.2, right? 2 here, 2 here. So this would be your Q3. All right, so that's the manual method of doing it. Let me show you the formula method. So for the formula method, let's say you want to find Q1. Q1 is a quarter of whatever n plus 1 is, where n is the number of data values. So it would just be a quarter of, how many data values do we have in total?
11.
So 11 plus 1 would be
11.
12. What's a quarter of 12?
3.
3. Yes. So it means that it would be where the third data value is. Do you see we get the same thing here? Look, 1, 2, 3. That's where it is. And likewise, if I want to find Q2, what do you think would be the formula for Q2? It would be half, right? Of n plus 1. And Q3 would be 3/4 of n plus 1. So that's the formula method to find them. Yeah, that's the formula method. And as I said, for this course, you will not have to use the formula method. You can go ahead and just do it the manual way. I'm okay with it. Yeah, it's okay. All right, so these are our Q1, Q2, Q3. Now for the box and whisker plot, we also need the highest and the lowest observation. We need that for our box and whisker plot. So let's go ahead and start with the box and whisker plot.
It starts on 50.
Yes. But I'm just gonna do a regular scale. So I'm just gonna do a number line. And I'm just gonna start at 10. And you don't have to always start at like at 0. You can always just scale it. So sometimes when you do a diagram, some people will do something like this. So let's say they don't want to start all the way at 0. You could do like a squiggly line. And then you could just, and this is mostly used in like when you're doing histogram and so forth. It's not popular. Lot of books just ignore it, but in the old school, they would use like a little squiggly line, and then you could maybe start this at say 50. So what this is saying is that, data values come before that kind of thing. But because we don't really have data values less than 50, we just start at 50. That's one way of doing it. It's not, yeah, it's not really, yeah. But I rarely see it though in modern textbooks. I rarely see that squiggly line. Even have you guys seen it in your stats, like when you do histogram? Yeah, I rarely see it these days. Back in the days, and I'm not old. Even when I did stats in high school, like when we were doing our histogram and those stuff, we had to use squiggly lines. My teacher was really strict on that. But anyway, um, so I'm just gonna start. So this is 0. So let's use a scale of 10. So this would be like 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. One ten, 120. So for your box and your whisker plot, you're going to go ahead for me and let's start with what we already know. What is Q1? We're going to create the box. What is Q1?
68.3.
68.3. So that's going to be close to 70. So about here. And what we're going to do is to create a box with the quartiles. What is Q2?
3.9.
So maybe that's somewhere about here. What is Q3?
98.2.
So close to 100, right? And these are not drawn to scale. So this is our Q1, Q2, Q3. And then look for your lowest observation. What's the lowest observation? 59, so that's close to 60. And then you draw your tail or your whisker. We call it the whisker. That's where the box and whisker come into play. That's your lowest observation here. And what's the greatest observation?
100.
So that's a little bit after 110. So about there. And that's what your box and your whisker plot looks like. You'll have the lowest, the highest, and then the box will show the quartiles. And from this, we can get a lot of information about our data. We can look at stuff like, is it symmetric? Is it skewed like to the right or is it skewed to the left? Those kind of stuff. And where the tail is would kind of tell you where the skew is. If you have a longer tail on the right, it's skewed to the right, meaning your data is positively skewed.
Is that an skewed right there?
Slightly, but not terribly, yes. Yeah. But as you can see, you have a longer tail to the right, so it's slightly skewed to the right. All right, let's do another example. So in this example here, this is what I want you guys to do for me. We are going to create a box and whisker plot for the following. And I also want you to state if the data is positively skewed. Positively skewed mean to the right. Tail is to the right. Negatively skewed Negatively skewed mean that it's skewed to the left, or if it is symmetric. Symmetric would mean like it's not skewed to the left nor to the right, it's central. So the first thing you're going to do is oh, I haven't given you the data. Oh, I haven't. All right, so we have 10, 35, 41, 44, 45, 53, 60, and 65. Is it already ordered for you, or do we need to order it? It's already in order, so that's good. And in this case, I'm going to show you that the formula and the manual method that we have been doing will give us two different answers. But as I said, you can go ahead and use the manual method. It is acceptable. So first of all, let's go ahead and find our Q2. What do you notice? We have two middle values. Do you see that? So it means that Q2 will be the average of the two. So Q2 will be 44 plus 45 divided by 2, which gives us 44.5. Very good. Now, over here, we have 4 items. So what's the middle of over here? Average these two. So Q1 would be 35 plus 41 divided by 2, which is 38. And likewise, Q3, the average of these two, Q3 would be what now? 53 plus 60 divided by 2, what do we get? 56.5, is it?
Yeah.
Yes, 56.5, Q3. All right, so that's if you use the manual method. That would be the best estimate. All right, but let's look at the formula and see what we would have gotten. All right. So let me just say, what if we used, no, we use the formula. So Q1, and I'll just do Q1. As I said, you don't have to use the formula. You can do the manual way. Q1 would equal to 1/4 n plus 1. How many data values do we have? 8. So 8 plus 1 would have been what? What's 8 plus 1? 9. What's 1/4 of 9? 2.25 or 2.25, right? So if you look at 2.25, it's telling you the position. Where would that position be? It's definitely not directly in between 35 and 34. Because what they're saying is this is the second value, and then you want it quarter way between 35 and 41. Right? Quarter way between. So it's not directly divided into 2, as you can see, as what we did when we did our first computation. So what would be quarter way between? What's the difference between 35 and 41? So 41 minus 35 would give us 6. Isn't that so? And then quarter, we divide it up into quarters now. So divide that by 4, and we're going to get 1.5?
Yes.
1.5, right.
So that's plus 35.
Right. So basically your Q1 would be the 35 plus go a quarter that way, it's 1.5, and that would have been different from what we got originally. This would have been 36.5 if we were using the formula, right?
That is big difference.
Yeah.
Yeah.
But it's okay though, because as I said, both methods are accepted, and if you use technology, we don't know like how Excel or another formula what they're going to use, and it's usually will not cause much of a problem in your data processes. So yeah, it's not a big deal, right? So what people will do is, so if you're like working for a statistical firm, they will have their way of doing things. So what you do at Anthem, you may not do that at Bank of America when they're looking at their data. It really depends on what, you know, what they're looking for, that kind of thing. So
I just want you to know the basics of it.
right, right. I remember one time I spoke to somebody who works in the federal government, and he was saying to me that like most companies like to hire people with a lot of experience. So he was saying to me that people like me, he would rather to hire because they train you how they want you to do their stuff. Whereas if somebody coming from another company and they're like, but this is not how we do it, So,
Yeah.
so that's what he was sharing with me, that a lot of times, because people do things differently. It's not a set rule that, it's this method or that method. It's what you're looking for, really. All right. But as I said, I just did this to show you, because if you go further into statistic, I don't want you to think that, oh, I taught you foolishness. There are different methods. All
Is
right.
that considered more specific?
Yes, I think the formula method is like this here, I think is more accurate.
Okay.
Yes. Mhm. It takes more work, as you can see.
Right.
But I am okay if you guys just do it like this. It's perfectly fine at this level for me. All right, because your data values will be very small for this course. As I said, it's not an advanced stats course, it's just an introductory to statistics. So I'm okay with it. Now let's go ahead and look at our box and whisker plot now. And you will see that whether you use the 36.5 or the 38, it will not have much different. It will not have much of a different impact on how we interpret the data as to what the data is saying to us. Do you see what I mean? Yeah. Right. So what's our Q1? What did you guys count by, 10 or 5? I'm gonna count by 10. So 10, 20, 30, 40, 50, 60. I can stop at 70, right? Yes, 70. What is our Q1?
38.
Q1 is 38, so that's close to 40. What is Q2?
44.5.
So that's somewhere in between 40 and 50, close to 45. And what is Q3?
56.5.
56.5, so about here. All right, so that's Q1, Q2, Q3. What's the minimum?
10.
10. What's the maximum?
5.
Okay. What do you notice about this data? Is it symmetric, skewed to the left or skewed to the right?
Skewed to the left.
Skewed to the left. Because we see that the tail is to the left, longer tail to the left. So it's, in other words, we can say that it is negatively skewed. That's another term for saying that it is skewed to the left. It is negatively skewed. All right. Now, there are times when you have outliers in your data. So I'll make a note here for you. So if any outliers are in the data set, then they will be to the right or left of the minimum or maximum value let me fix that. They will be to the right or left of the maximum or minimum value, respectively. Yeah. In other words, if I have outlier to the right, it will be to the right of the max. Outlier to the left of the max. What this means is, so let's say you're doing this, right? And oh, this didn't tell us what the data is saying, but let's say this was showing some data within this range here. And let's say out of the blues, you came across a data value when you're doing your analysis that has, let's say it was like 1025. Let me fix that. Right? 1025. You will know that that must be an outlier. It could be like maybe it's a typo. Maybe they meant to say 125 or 25 or, you know. So there are times when you're doing your analysis and you may see outliers. And so on the diagram, you may see like a little asterisk to the right that shows that there is some outlier in the data. And sometimes these can be typo. Sometimes they are real though. Like I remember I was doing this statistic project and they were looking at like bedroom sizes of houses in a community. And like most of them were within like, let's say between 1,500 to 2,000 something square feet. And then there was this one house that was way off the chart. So you as a statistician looking at that may think, maybe this is a mistake. So what you would have to do in a case like that is to maybe go and verify that it actually exists. Sometimes a research may call for that. You may have to go in and look and say, oh, maybe you have a celebrity that lives in this neighborhood. It's possible where their house is just, you know, off the chart. Or it could be a typo. So you just want to verify that. So sometimes there are outliers in your data values. Yeah. And a lot of time for statistical purposes, we ignore them. But as I said, it depends on what you're doing. You may want to go and verify and not just ignore it because it could have a significant impact on your analysis as to what you're trying to present on. Okay, so this is your minimum and this is your max. We should actually label that, right? Minimum and max. All right, so that's basically it. Next class, we are going to be looking at our final topic in statistics, and that's going to be the normal distribution and how to calculate probability using the standard normal distribution table. All right.